All right, good afternoon. Welcome everyone, and thank you for joining us today. My name is Steve Meek. I'm the Regional Sales Manager for the Midwest region of the United States. I joined Wenzel back in January of 2019, and as of May this year, I took on an additional responsibility of managing aftermarket service and calibration sales as well. Today I'm joined by my colleague, Drew Pensko. Drew?
Thank you, Steve. As Steve has mentioned, my name is Drew Pensko. I'm an applications engineer here at Wenzel America, recently joining Wenzel America in July of 2020, where before I was an assistant plant manager for a small tool and die company.
Thanks, Drew. So today, Drew and I will be talking about how to measure more parts faster, featuring the Wenzel XO Series CMM. Our machine today will be equipped with the Renishaw 5-axis PH20 probing system and WM Quartis software. We'll also have some time designated for a Q&A session for the end of this presentation, so there should be a chat box for questions on the right side of your screen. If you have any questions or comments about anything you've seen today, please send them in. We'd love to hear from you.
So, Steve, can you tell us a little bit about the frame today for right now? The XO frame?
Yeah, absolutely, Drew. So today what we're working on is the Wenzel XO 8107 CMM. That's in XYZ format, so a measuring envelope today of 800 millimeters in X, 1 meter in Y, 700 millimeters in Z. The XO series is our entry-level CMM. This is a traditional bridge-style machine available in a variety of sizing, ranging from smaller 555 size all the way up to the 1027, making them a really nice option for smaller handheld type parts or even mid-sized to large parts like the engine block you'll be seeing here in just a bit. As you may have heard us say before, premium accuracy is now standard at Wenzel. That being said, we do offer this frame in 2 accuracy options, standard and premium, ranging from 2.8 microns all the way down to 1.5 microns. Drew, you asked what my favorite thing about the machine or what I like about the machine. Personally, I think the XO is great for its versatility. We can configure the XO to run with the PH10 SP25 combination for your tactile scanning applications, or the 5-axis PH20 for your higher volume touch trigger applications, and also it's capable of running the full line of optical sensor technology from Wenzel. So although we do refer to these as our entry-level machines, these are still highly versatile, highly efficient measuring systems. Something else I really like about is more of a fun fact about Wenzel, I guess, is we're the only CMM manufacturer who owns and operates their own granite facility. This is important because it allows us to build our machines entirely from granite and from the same granite source, which ensures you the highest quality from the foundation up on a frame that's truly designed and built to last. Also, all of our frames feature a true one-piece granite table, including the entire Y-axis beam, with our bridge and Z-quills also being made of granite, except those are core drilled, allowing us to keep the machine speeds up and overall weight down. This structure allows us to maintain the tightest overall system accuracy and a universal thermal expansion throughout the entire frame of the machine.
So, Steve, this sounds really nice, but what does that mean? So what does that mean for the customer?
Well, Drew, what that means for the customer is it means a high-quality machine with low cost of ownership. It means reliable, long-term mechanical stability. It means versatile measuring systems readily available at affordable prices.
So, Steve, we're talked about the XO frame. So let's go and talk more about the PH20 that we're going to show off today.
Okay. So equipped on the machine today is the 5-axis PH20. This is a probe head by Renishaw. This is a high-speed touch trigger probe head. It's specifically designed to reduce inspection bottlenecks by maximizing your machine speeds and machine throughput. Unlike traditional 3-axis probing, where we're limited to 7.5 degrees probe indexing and positioning, the PH20 has infinite indexing and infinite positioning capability. This unique head motion technology, as they call it, allows for many of the measurements that you're taking to be probe head only instead of the machine's mechanical structure only, which really greatly improves the system repeatability. This design also allows programmers to access normally difficult part features at speeds of up to 3 times faster than traditional 3-axis probe heads like your PH10. And again, this is kind of a lot of words about the probing system, but what does that all really mean to you? As you're seeing on the screen here, it means faster programming times, it means faster inspection cycle times and machine throughput, and it means faster calibration times. No more spending valuable minutes and even hours calibrating your probe rack. All of this adds up to more parts faster, right? Increased productivity, reduced costing. So now that we've talked about the hardware, let's get into the software side. What we're looking at today is Wenzel's proprietary software, WM Quartis. As Drew will show you over the next 10 to 15 minutes, this is a Windows-based and object-oriented software. It provides a very powerful and fluent user-friendly interface. Quartis offers great connectivity with full CAD import-export capabilities, high-level GD&T programming, and world-class reporting and SPC functionality that are already built into the software. Being a novice programmer myself, two of the things that I really like about Quartis are the self-help menus and then the offline programming ability. With very detailed step-by-step direction readily available at the touch of a button from literally anywhere in the interface, and the ability to work or in some cases learn offline away from the machine, Quartis makes it very easy to self-serve and learn very quickly, really making it an excellent platform for programmers of all experience levels. So with that said, we've talked enough. Let's get into the fun stuff. Drew, could you get us started here with a view at Quartis?
No problem, Steve. So I'm going to just go over and switch to Quartis real quick. And here we can see, here is our Quartis software. As Steve has mentioned, this is Windows-based. So we have a layout that's very similar to any sort of office suite you've used with the different ribbons and our different options. Here's we have the XO frame right here, and we have the PH20 and our engine block right here. So I'm just going to go ahead and get started because we're here we need to measure parts fast, so let's go and measure, let's get this engine block done. All right, so we're going to go ahead, and you can see that the PH20 is moving in position to each of these little points on this plane right here, and the head is just doing all the work. So when the machine gets into position, it's limiting that natural dynamic error that you get because the head is the two drives in the head are going to work. And as you can see here, after doing all these different A and B angles for that face, we went to A9. We've got a nice A90 position right here, and we're going to get our cylinder done real quick. I'm going to go ahead and just close our program window down just a hair and reposition ourselves so we can get a better look. So you can see from afar that I'm going to show off that the machine is very stable right now and that the PH20 is going in, getting in all these quick, fast points. What Steve hasn't mentioned about the TP20 is that, or the PH20, is that it uses the TP20 probe that's been standard with Renishaw for a while. So all your TP20 different modules are compatible with the PH20. So anything that you have that's TP20, and you say you're going from PH10 to PH20, all those different TP20 modules you can use with the PH20 to really add to your inspection arsenal. And then go in real quick, and you can see right here we've went through, and now we're going to go ahead and show off that we can do, traditional. We can do, standard 3-axis probing with the PH20. And PH20 runs on Renishaw's UCC server, which is based upon the I++ DME command protocol. And we're going in, we're finishing our points real quick, and then showing off what the PH20 does best, getting points fast. So we're going to go through this top bore right here and just keep going around, no problem. Right here, and then go ahead to this surface scan right here. So you can see right here, this is our Quartis software. That's while the PH20 is going and taking points real quick. I have the progress window, you know, where we see where we are in the program. And right underneath here, I have something that's called the quick access toolbar. So you can set up all your shortcuts here in Quartis. I'm going to be using this to change the view on the CAD model right now in Quartis. So after we go in and finish our little pockets right here, we're going to go to the right side of the engine block, and then I'm just going to go ahead and jump down there. So be aware, we're going to have a little jump right here. I'm going to go ahead, and I already changed that view, so I didn't have to go over to change my display or move around my mouse. You can customize all your different views, so when you're inspecting, you can just go ahead and change. It's the nice quality of life. And in the program, we have, as I've mentioned, there's not a lot of indexing and angle changes going on, because with the PH20 and a 5-axis system, I'm going to go ahead and jump again real quick to behind our parts so we can finish our engine block. Go right here, see the PH20, different type of reverse helical point stand right here, points right here, go around counterclockwise, get our points. And we are done. And as we said, as Steve's mentioned, faster throughput. We're already done and loading our program. So this is something that's really handy, especially if you have for touch trigger applications to increase that throughput. A 5-axis system with the PH20 is a nice way to get more parts done faster. And you can see right here, we have our report that comes with Quartis, where we have right now a nice, I have a table with my cylinder right here with our points, a table style report right here, easy to set up. This is just a template that comes with Quartis, so with the templates in Quartis, you have a lot of options to, customize. As I see here, as I show off here on page 4, you can see the CAD with the little bubbles right here from our different circles we've taken and the nominals and the actual values. And then something I've done here on page 5 is taken that the point scan of the surface right here with all our points, and then go ahead and just throw those on a CAD model right here so you can show exactly where the points are and tell, hey, we're off by a little bit right here. We need to take some stock off right here. You can go ahead and show them the color grade and it would be red. So here's Quartis. I'm going to go in. So with Quartis, we talked about Windows-based, so I'm going to go into kind of the structure of how Quartis operates, which is based on a database system. So I'm going to go ahead and click the database window, and you can see this is very similar to a Windows Explorer type view where we have our measurement database and our system database. The measurement database holding all the different programs, your measurements, all your graphics, which store your models and views, and then all your features from your measurements. It's all nice and organized in here, and even copying and pasting is as simple as right-clicking the program right here, copying, pasting, and then just renaming, which is really easy. And then there we go. I've already have the copy of this program right here. Really simple. And then in the system database is where Quartis stores its the different probe systems right here, your reference spheres, and a palette coordinate system. So if you want to bring those different coordinate systems across different work pieces, you can store that in the system database. So Steve, I'm going to show off a little bit how Quartis measures things. Enough about the structure. Let's see Quartis in action. Enough talk. Let's see this thing go. So I'm going to go ahead. We're at this A0, B0 traditional position. But I'm going to go ahead and just click on this tiny little hole right here. Right click, left click to accept. And you can see right here that Quartis has generated a path. This yellow line right here and the red dot for signifying the ruby. And I go into my distribution right here. It says we're taking a circle. You can change the sector, how many points you need, but important to this is the safety plane. So before we go into the hole right here, we're going to go 25 millimeters above the part, and let's measure. So right here, I'm going to zoom out. Page 20 moves. Angle change. Really quick. There's the points, but oh, I missed something on top. But I just want to go ahead and measure. I don't want to do an angle change. It's a waste of time. Especially with a 5-axis system, because we've definitely just gone there and went from A0, B0, no time spent at all.
So as you can see, one of the things that our customers like is the versatility, right? You're saving a lot of time with programming, not entering those angles that you would traditionally with a 3-axis system. Be changing from one face of the block to the top deck of the block. But Drew, traditionally, circles are one of the easier things to grab. What about something a little more challenging, like say the pocket or the pool, as we call it?
Yeah. So
on top there. What if you do that?
Oh, no problem, Steve. So I'm going to go ahead and select our curve right here. Just go ahead and select. Oh, and I'm going to zoom in just a little bit. Make sure we're nice and centered right here. Go ahead and click on this pool right here. Left click once, right click to accept. And you can see right here, we've generated a path for this pocket. But this looks like we're not getting enough points, or say there was something wrong. We know there's something wrong in this top section right here of the cast. So I'm going to go to the distribution window again, and I'm going to go ahead and delete the border points. And then just select a custom scan. So let's say we don't need to go around the whole pocket. We just need to do this section right here. Go ahead, and then there we go. Left click and right click, and here we go. I have all these points. Let's add 5 more points real quick. No problem. Simple. Added 5 points, and I'm just going to start. Here we have the safety plane. And here we go, Steve.
So just reiterating the point, right? So you're not entering these angles. They're automatically being generated, even if the surface is curved. If it's this pocket, it's nothing that's traditional, right? It's automatically detected based on the CAD.
Yeah, based on the CAD and the coordinate system you have active, PH20 is going to find the optimal measuring angle. So it's saving you a lot of time. Where sometimes you have those weird parts where they're not in a traditional 3-axis system. You only have 7.5 degrees. Sometimes this one's about it's not really an A90. It's not really like a A75. It's kind of like a 76-ish. That PH20 with the 5-axis system will get to that 76 angle, and if it's going to find it and you're going to get the measurement there.
Unlimited. Again, we're talking about infinite indexing, right? It's one of the advantages of PH20. So what about if you were to go and maybe edit something that you've already created? Maybe your print changed, something changed. You want to go in and adjust something that you've already done in the program. How easy is that to do?
So yeah, the dreaded engineer comes in and says, "Hey, we've got a revision to do." So we have a revision, no problem. So I'm going to open up the program window just a bit, and then I'm going to go down. Let's say we need to go into the top right here as I've organized, and this big circle right here. Okay, so I double clicked right here to get inside the edit mode, and I have circle 5, and I can go in and manually change all the different nominal values here according to, say, the CAD's not ready, but they're making a revision. You can go ahead and change your XYZ, no problem. Or distribution right here. Go in and, we need more points, for example. Add more points. And then we can also just go ahead and accept. And we've changed it, and to, make sure we're running all right. After we're done editing, we're just going to run it. Just right-click and hit execute the selection. And we're going to go in and get all these points again. Right here 40 points. There we go. Almost as effective as a scan.
Nice. Very quick, as you can see, the PH20 just stayed in position using the head motion only there. That's one of the things we were talking about earlier being an advantage, right? You're increasing your repeatability of your system by using the probe head only as opposed to mechanical structure of the machine. But Drew, thank you very much for showing us how you created those and how to edit those. Again, Quartis is well known for its reporting and its built-in SPC. Can we dive into that a little bit further? Maybe show us how you can make some adjustments in the report?
Yeah, no problem. So as I close out of here to confirm the fact that my program has changed and updated, you can see sometimes we have the 40 points. All right, we're good. So as Steve was mentioning, Quartis does come with SPC capabilities. So I'm going to open up the statistics window right here where my cursor is. And then we're going to load in all our data. Our data's loading. And here we go. So here we go. We can go and change the evaluation method right here. So we have process capability and machine capability right here. We can select which one. Let's go with process for now. 1 second. And then I'm going to go to the filter real quick. So here's the filter. So we can limit via a selection of the features right here. So I can go in and select this and go in, handpick which features I need for SPC. I can also sort this by the deviation for features within a certain range. But I can also go in by measurement type, which is really handy. So if I go to the measurement filter and select it, I have the different options for filtering. So I can select, say we need to, we need the first 10 runs. We need to know where we're at starting off. So I go to the measurement right here and then select the drop down. I have the ability to go from, the first 10 measurements. Or let's say that's not good. We do a ton of these parts. We need a time range. So you can select the time interval and go, let's say we need it from the week of the 17th and then go back to August right here and then finish the week off on Friday right here for the 21st, and you can set the range there as well. And then here, I'm going to go over and select a feature. I'm going to go ahead and select feature number 18. And right here, you can see the data page with our CPK right here. And then I can print this out or go over to the overall view, and we can see the trend diagram with the different measurements and our readings and our actual values. And we can save those and print those by just simply right-clicking, save, and then printing. And we also have a histogram as well with our measurements and with our actual values and the frequency. And see, so that's the statistics side. Let's go into more of the reporting aspects. So I'm going to go over to reporting and go back to, our table style report. So I'm going to go to page 2. And here's the thing. So we have every time it's happened, we forget to report something. How easy it is to, add something that you simply just kind of overlooked. We can double click on our table right here, and we can add our features right here. Here's all the data and all the features we've collected. So let's say we forgot number 30. Let's add number 30. And I can also position this in the report right here as well by moving up and down. This is fine for now, so I will accept the changes and go in, and there we go. We have 30 right here. And I can also remove things as easily as well. So I'm going to go to our little CAD report right here with our nice bubbles. Now let's see. Yeah, we can take away cylinder 6. Cylinder 6. And then we can easily just go ahead and then accept this view after we've made the revision, and cylinder 6 is no more. So you can easily add and remove things to the report in Quartis.
And you're just working from a stock template too, right? So you have a template here and you're just kind of customizing it as you see fit?
Yep. So the world is yours when it comes to reporting your course. The templates are a nice starting point, but if you have, say, like an Excel report that you already use, you can go ahead and save the report in Quartis. And you have your different options, such as PDF and text, but you also have the nice CSV option, so you can take your CSV, and then if you have a report set up in Excel already, just take from the CSV file and then just import those to your report if you don't want to use Quartis, the report, if you like the reporting. So we're getting pretty close on time here, Steve. So any quick questions before, if we got any questions coming in, or you got any questions for me?
Yeah, Drew, I'm glad you mentioned it. Just going to do a quick recap here. So today we covered the reliability and flexibility of the XO frame. We talked about reducing cost by increasing productivity and throughput with the 5-axis PH20, and Drew showed us how quickly and easily it can be to program with Quartis. As you just mentioned, we said we'd leave some time for Q&A here at the end, so I'm going to go ahead and open up the floor for discussion. It looks like we've had some questions submitted so far, so let's take a peek at a couple of these. Drew, first one for you, I believe here. Does Quartis have ISO or ASME standards built in?
So not only does the Quartis have ISO and ASME capabilities, let's say you're talking, Steve, about GD&T and the help function with Quartis, so let's go to the position icon real quick. Let's go to position. And you can see right here that reporting true position is very similar to a GD&T print. You know, I'm going to go over to my graphics window real quick. So you select your element right here. You can go through this window, but I forgot what I named it. It's one of those things I'm going to go ahead and select the mouse button real quick, and then go ahead and pick on my CAD model, and there we go. It was cylinder 1. That's what I was looking for. So, and then I can, set my datums right here, and go ahead and select my datums. Not only that, as I quickly go and grab these, datum A, and right here. So we're in ASME right here on the left, but I already have everything reported. If I change it to ISO, will everything, kind of get screwed up here? Nope. I go to Quartis and easily make sure, now I'm in ISO 5459 with case 355. And then I can evaluate. So we got another question coming in, Steve, here. So this customer is, he likes this PH20, he likes the PH20, but he currently has a Wenzel with the PH10. Can he use the old programs if he upgrades to a PH20? So we can definitely do that, no problem. I've actually generated this program from a Revo program I've done, which is a 5-axis scanning system. And by importing this program with the PH20, Quartis has adapted the program already. So not only does it have forwards capability with your PH10, it has reverse capability as well from if you're doing a scanning application. The PH20 and Quartis will change the program will adjust itself to being a touch trigger application.
And that's just as quick as turning it from 3-axis to 5-axis mode on and off, quick toggle.
Oh yeah, no problems there.
Okay, thank you for that question. One more very quickly here, Drew. Could you show us what types of CAD files we can import?
Oh yeah, so I'm going to go ahead and get out of our GD&T window and go to the Quartis menu real quick, and then I'll show off real quick that we can import CAD models and add simple. And then with all these CAD files right here, we have our different options for, IGES, DXF, SolidForm, SolidWorks, and that's it.
Okay, awesome. Thank you, Drew. And thank you, everyone, for the questions. We are creeping up on our time limit here, so we're going to wrap things up. I just want to say thanks again to everyone for spending your afternoon with us. This means the world to Drew and I. We do have a list of questions that we have not been able to get to yet, but we do have your contact info, and we'll follow up with you in the next coming days. The slide that Drew will find for us here shortly has our contact info as well as the Wenzel America link where you can find more info on what we've shown today. We'll leave this slide up for a couple moments here. Should anyone want to take down our contact info and reach out to us before we follow up with you. Other than that, we are going to wrap some things up. Thank you very much again for joining us for the Wenzel Expo. Everybody have a great evening, and we'll talk to you again soon.
Yep, thanks for coming out, guys. We appreciate it.